Hello all, this is about water, hydrogeology, and this the material you might have already seen. So we are not going with the literature or the romantic literature that is about water which is present here that you can read later, and I am directly going to the content which I wanted to discuss with you. These things are already known to you, you might have seen this. Water is the elixir of life, without it life is not possible. These things are not known to us. Although many environmental factors determine the density and distribution of vegetation, one of the most important is the amount of precipitation. We know that. ഒരു പ്രദേശത്തെ മഴയുടെ അളവ് തന്നെയാണ് ഒരു ഏരിയനെ മൊത്തത്തിൽ നന്നാക്കുന്നതും മോശമാക്കുന്നതും. കൃഷി ഫ്ലറിഷ് ചെയ്യണമെങ്കിലും that can flourish in some deserts but only with water either pumped from the ground, ഒന്നുകിൽ അവിടെ തന്നെ വെള്ളം വേണം, or it should be imported from other areas. അതുപോലെ തന്നെയാണ് സംസ്കാരങ്ങളുടെ കാര്യമായാലും. Civilizations have flourished with the development of reliable water supplies and then collapsed as their water supplies failed. That is, everything is connected to or dependent upon water. And this is simple maths. A person requires about 3 liters of potable water per day to maintain the essential fluids of the body, let alone all other requirements. Just to keep the essential fluids of our body, a person requires 3 liters per day. Just keep in mind, and all other details are there, you can read it later. And coming to the terms hydrology, hydrogeology and all. Hydrology is the study of water. In the broadest sense, hydrology addresses the occurrence, distribution, movement and chemistry of all waters of the earth. That is hydrology. That is the occurrence, distribution, movement and chemistry of all waters of the earth. On the other hand, hydrogeology encompasses interrelationships of geologic materials and processes with water. That means in hydrology, what we have seen, in hydrogeology, we have a relation with the geologic materials, interrelationship of geologic materials and process. The process of occurrence, distribution, movement, and chemistry, of course. These are all there in hydrology, but the geologic component is discussed, or the interrelationship of all these things with the geologic material is discussed in hydrogeology. That is the importance. Hydrology, many people learn, including civil engineering people. They are talking about hydrology, but we people are dealing with hydrogeology. And there is another term, geohydrology, and which is used as synonym for hydrogeology, but it is more properly an engineering aspect. I mean, it is dealing more properly an engineering aspect of this part, that especially the subsurface fluid hydrology. Okay, the creation and distribution of precipitation, that is the origin and distribution of rainfall, is heavily influenced by the presence of mountain ranges and other topographic features. Running water and groundwater are geologic agents that help shape the land. That is the thing that we should keep in mind. Why geology is important? How hydrogeology is important? Running water and groundwater are geologic agents that help shape the land. That is very important. The movement and chemistry of groundwater is heavily dependent on geology. The movement and chemistry of groundwater is heavily dependent upon geology. This point also you should keep in mind. Hydrogeology is both a descriptive and an analytic science. That is, we can discuss that without any mathematical relation. Simply as a descriptive science, we can deal with hydrogeology from one end to the other. But at the same time, it is an analytic science. From point 1 to point 100, we can say we have analysis of chemical data, analysis of hydrogeological data, analysis of hydrogeophysical data. All these things we can have, make it an analytic science also. In which way you want, you can do that. That is the beauty of this subject. And this is a thing that is an account of the water supply of the world would reveal that saline water in the oceans accounts for 97.2% of the total. That is, what is the total water available on the earth? 97.2% is saline, that is present in the oceans. Land areas hold 2.8% of the total. Ice caps and glaciers hold 2.14%. Groundwater to a depth of 13,000 feet, that is around 4,000 meters, account for 0.61% of the total. That you see, the groundwater percentage, 0.61% of the total. Soil moisture, 0.005%. freshwater lakes 0.009%, rivers 0.0001%, and saline lakes 0.008%. More than 75% of the water in land areas is locked in glacial ice or is saline. Okay, this is the picture again, shows the percentages. And now coming to the hydrologic cycle. As we have seen these things, as we have learned all these things from class 1 onwards, here we are relating that to the geology of the area. We had learned this, we might have seen the environmental part, the atmospheric part and all. And hydrologic cycle is nothing but it's an unending circulation of water through the hydrosphere, the atmosphere and geosphere, and of course biosphere, which makes the hydrosphere. All these things together, wherever water is present, we call that as hydrosphere. Okay, so it deals with, it begins with water from the oceans. The cycle actually has no beginning and no end. As most of the water is in the oceans, it is convenient to describe the hydrologic cycle as starting with the oceans. Water evaporates from the surface of the oceans. The amount of evaporated water varies, being greatest near the equator, where solar radiation is more intense. That is where all these weather belts are there. Evaporated water is pure because when it is carried into the atmosphere, the salts of the sea are left behind. Water vapor moves through the atmosphere as an integral part of the phenomenon we term the weather. That is the starting point of all kinds of weather systems. When atmospheric conditions are suitable, water vapor condenses and forms droplets. These droplets may fall to the sea or onto land and may re-vaporize while still aloft. Again, that can happen. Precipitation that falls on the land surface endures various pathways of the hydrologic cycle. Some water may be temporarily stored on the land surface as ice and snow, or water in puddles, which is known as depression storage. Some of the rain or melting snow will drain across the land to a stream channel. Okay, this is termed overland flow. If the surface soil is porous, some rain or melting snow will seep into the ground by a process called infiltration. Okay. Below the land surface, the soil pores contain both air and water. The region is known as the vadose zone or zone of aeration. Water stored in the vadose zone is called vadose water. At the top of the vadose zone is the belt of soil water. This is the zone where roots of plants can reach. The soil water contained in the belt of soil water can be drawn into the rootlets of growing plants. As the plant uses the water, it is transpired as vapor to the atmosphere. Under some conditions, water can flow laterally in the vadose zone, a process known as interflow. Okay, that is the flow, the horizontal flow of water in the vadose zone is known as interflow. And all these things, the gravity, the capillary fringe zone and all other things are there. At some depth, the pores of the soil or rock are saturated with water. The top of the zone of saturation is called the water table, that is known to us. Water stored in the zone of saturation is known as groundwater. It then moves as groundwater flow through the rock and soil layers of the earth until it discharges as a spring. And there are a few more terms. Water flowing in a stream can come from overland flow or from groundwater that has seeped into the stream bed. That is very important. This relationship you should know. Water flowing in a stream can come from overland flow directly, the precipitation that has reached the land, they may come into stream as overland flow. That is the flow over the land, or from groundwater that has seeped into the stream bed. Okay, the groundwater contribution to a stream is termed base flow. And that beautifully happens when during the rainy seasons, the water that is captured in the forest area or the hilly terrains or small hillocks and all, that might be stored there. And when the water level goes down in the streams, this water that has been captured in the forest or the hillocks may be released. And that is called as base flow. While the total flow in a stream is runoff. Okay, the total flow of stream that is going through a stream is known as runoff, but the base flow is the contribution of groundwater into that. Water stored in ponds, lakes, rivers and streams, that is called surface water. That you must know what are all these terms, that is it is for that. And then there is evaporation, transpiration and evapotranspiration. Transpiration by plants and evaporation from land surface is together known as evapotranspiration. Okay. Then we have a term called magmatic water, that is the water contained within magmas deep in the crust. If the magma reaches the surface of the earth or the ocean floor, the magmatic water is added to the water in the hydrologic cycle. Okay, you know what happens if the magma reaches the surface of the earth or the ocean floor, the magmatic water is added to the water in the hydrologic cycle. Okay. But the steam that is seen in with some volcanic eruption is groundwater that comes into contact with rising magma and is not magmatic water. That is, that steam is not produced from magmatic water, but the groundwater that comes in contact with the rising magma. So these are all the things that we have to see, the important points that we have to discuss in the first topic. Thank you for watching.